that's the right temperature for PLA. So we go back and unload the filament. Unload. Yeah. So you can see it can. Yeah. So immediately it does that. You pull it out. The one that remains. Yeah. So this one, this is what it does. It takes the whole filament and pushes it through a very tiny nozzle and melts while melting. That's why it has this room, this knot. Yeah. It's being pushed as it's melted to this. This one is about 0.8 millimeters. Yeah. And this one is about 0.4. So this has a very fine. So it's modified. Very fine. So higher resolution. Yeah, higher resolution. General resolution. This is like okay. This is 1080. Yeah. So when that is done, you ensure that you're still holding the right temperature. If you try to jam your filament, right, when the temperature is lower, then appropriate for the kind of filament you'll get instructions about nozzle temperature. Nozzle should be 205 to 212. Now we are 250, right? Slightly the higher. And then the bed should be at 40 to 60. And here the bed is 66. So this one will generally tend to be hotter because we don't have any. So it tries to compensate. So if you see it at 61, don't be so alarmed that it will fail. It tends to compensate because of the and now we have that. So it's really struggling to get hot. And to maintain the temperature. So before loading your filament, always observe if you have kinks and weird stuff that will fail. You cut. So when you cut, as we prefer at 45. Also it's sharp. This one. Cut at 45. This one is not. Someone did that. People take his position in your makeup. Yes. Yeah. That one is enough. As long as it's smooth and sharp and pointy up, we're trying to push it into these rollers. If you can see, there are two rollers up. These are rollers. Yes, you can see there. Yes, there are two rollers. One is on the motor and one is the idler. So the motor, they have teeth. They grip onto the filament and pull it into the extruder. So it's called an extruder motor. Extruder motor. I think it's also right. Yes. Yeah. They always write extruder. So this is a motor that drives the filament into the extruder. You can see this silver shiny, this aluminum thing. That's the extrusion. This one, the spring thing. Yeah, the thing that looks like spring with. So this gets heat. It's a heating element. That's when we load our. Somebody showing. Yeah, it will pull it and it will start melting the filament. So if there were two different colors, you'll observe, and if the right color is not yet being extruded in the right proportions, we'll continue extruding until we get green. Well, because there's another one. You can also put another one, because we're only having green. Yeah, this is a single head. So you can only not at a time. But if you want multiple colors, you'll pose the print and the filament. So you can do multiple colors, but not like this guy will do it. It has a punch tower. Yeah, there's a punch tower that it can choose the filament at what point and what portion, so it can decide a straight column or what is on. So that makes sense. This one can only do this. Doing that this is open. Are you at risk of any electric shock? No, they did a good job saying electrical that it is properly armed. And if it is not properly armed, the controller dies. Okay. Yeah, they have seen the controllers die. Okay. So when that dies, you know there's a problem. Yeah. So that's set right. The nozzle is clear, and now you can proceed to doing your calibration. Most of the time, since we do our in-house calibrations fairly easily, if you want the full thing, we'll do the wizard. It takes as long as for this, about 20 or 30 minutes. But if you just want to see if your axes are the right one, it will go. That is what? Why? Yes. Why? Checking on. This is design. Okay. So why? And then design. And then X. So that is home. That is home. That point zero. Yeah, 000. Machine zero. Absolute zero. 0x, 0y, 0z. That's machine zero. So there we know the machine has its full range of motion, and nothing inhibits. So we'll proceed to doing the small calibration. We always do first, let's reset. Just start from as if the machine does not know anything. So it will go and it will try and calibrate the Z. And if something goes wrong, it will let you know. So it has to recalibrate and try. So this thing might make you stop and start again. Okay. So it jumps between the nozzle and the bed, and it will give you some errors. So it does get affected. We should do that, and it will measure the resistance, the amount of current the motor is taking. So now it knows that's the limit. Yes. In that direction. Yeah. And it will do the same. But here we have the sensor. It won't hit. Yes. So that's the limit from 0. So you have to put it all over. So in case your belt is tilted in a way, it compensates. Okay. You don't have to do it. So like now, from that point,
it's asking you to.
Yeah, I also show that if you don't adjust your Z, it just drops it on top of it doesn't smudge it. It's supposed to, you see, it's easy to, so you don't get good layer vision. But when you reduce your Z height up to the point, printed there. Oh, yeah. Is it even dropping? It's changed.
Live, yes. Maybe Abna, some of us don't understand what.
So we are dropping the Z lower and lower until umona hapa ishiki. Sindio? That means you've dropped it way too far. You've blocked the nozzle. So this one was too high. There was no, it was just dropping the how do you call it? The filament on top of the bed. It wasn't smudging on the bed. But when it's too tight, it blocks up it jumps up the nozzle. So there is no space filament to dispense the filament. So you won't get any print at that point. Yeah, and you might damage your pen, your motor and your nozzle extruder because you're building pressure and there's nowhere for the filament. So there's a fine balance. This one you have to do it manually, and this one has this one to have.
No,
So you do it.
this cannot do it.
This one can do it. So I think this one, this one does it.
But it's a good way of learning because you do it yourself, so you understand the calibration better.
Yeah.
So we need to master the art of this, the art of actually checking if it's touching the bed.
Layer
Yes. Because you can see, even here, maybe you can show you.
So
This is what it printed out because you can see, and there on the Prusa website, you can see also different quality. What
you see, this one didn't adhere to the bed. So all the print you're gonna, all the filament that will be laid on top of this one, it will be laying it and moving it around. So you'll have a big spider web. But you see, and that everybody, the whole, they need both. So this one has adhered. You can put it around and see how fine the attachment is to the bed.
Take this stuff and just that means rectum.
Yeah, it is merged onto the bed. That means any filament you put on top of it will not be moved. It will stay in place. Flexible. Yeah. Basically, we don't have a way of clamping.
This thing.
Yeah, this thing. So that tells you the nozzle height to the build plate is right.
Because height is
So this is the most important layer, the first layer. Because remember, the first layer is what attaches the whole design
onto this thing.
It's the
foundation. If the foundation is wrong, everything is really messed up. Yeah. So
like always in life.
Yeah. So it's easy to remove it, but sometimes we use other means of attaching stuff like how do you call it?
You have some glue.
Yeah.
Because at times you really try to adjust, but it's still not holding.
Yeah.
So you use some glue.
Some glue certificate.
Yes. So that's possible when you're doing big prints, very or smaller prints. Depends on what you're printing, and also when you're having samples, if you're printing something that needs multiple points of support, those support.
And also when your filament is a bit affected, it starts printing and then kidogo, there's a part which you see it's bending upwards. And before you know it, just a small knock, everything is off.
Yeah.
And you start afresh.
Yeah, we had a project where we lost almost 2 filaments because of that layer issue.
Roll like this one.
Yeah, you just keep on just printing 90%.
You've printed so much and then
The last 10%.
Just the worst.
Yeah, it's a bad feeling. You have to do this every time.
And that is why at times people put multiple prints so that you compensate on time. Because you can imagine if you are printing one after each other, so after printing this one, when you want to print another one, it takes you back there. So you waste some amount of time there. But then the danger of putting many is that when they get wasted, all of them are gone.
But sometimes it doesn't hit the bed. It doesn't hit the bed. Let's see what happens when it doesn't hit the bed. You'll see the type of adhesion between the filament and the bed will be different when the bed was hot. So sometimes it messes you up. You have to drop.
The bed.
Yeah, you will have to go and preheat it. This one has some good adhesion. So it's less.
Can you see?
Yeah, it's depositing
Can you see? Maybe you can.
layer by layer.
Maybe you can come.
Around.
It's happening.
It's happening. It's happening.
So it will do that layer by layer. That's why you hear that printing the whole weather station will take yeah.